So in this video, I will be discussing queues in detail with the help of few examples. So queues are dynamic collection of elements with LIFO and FIFO behavior. By that I mean that they are very fast for insert or delete operation at head and tail. And they are more generally used when the number of elements shrinks or increases a lot. So let's begin with an example. So first of all, how do we declare a queue? It is very simple. So let's say we have a queue of name q2 and we just have to write a square bracket, and inside that square bracket we just have to use the symbol dollar. So that's it. This is how we declare a. So queues have lots of methods and we will be discussing each of them in detail. So let me write an module and I will name it test, and I will declare a variable and I will give a integer value 1 or a int value, and after that I will declare a queue and remember queues are also of unpacked data type. So I will assign some elements to queue, and there's a difference between assigning values to the regular arrays and to queues. And the difference is that you do use curly brackets, but you don't use this symbol. You just use curly bracket, and that's it. That's how you assign any elements to queue. So since queues are dynamic in nature, you can just add or shrink the size during the runtime. And here we are just declaring some elements. So let's give it 3 and 4. Let me name it Q instead. And let's give it 3 values. Okay, 0, 2, 5. So we will be discussing several methods, and one of the method is insert. So I will begin with initial block. So what if I want J, I want to insert J in somewhere inside this queue. So to do that, I just have to write the name of the queue dot insert, and inside the bracket there are two arguments. The first one, I have to mention the position, that in which position I want to insert the value of J. So let's insert the value of J in the first position, which will be between 0 and 2. So to do that, I will write 1, comma, and I will write J. So first, let's check for any compilation error. Okay, what happened? Oh, right here. Okay, let's check again. Okay, now the code is fine. So now I want to print the value of the queue. Then I will use the dollar $stop. And I will just use %p. and I will write Q. So this is the value which we initialized, that is 0, 2, and 5. And using the insert method, I am inserting the value of J at the first position. So let's find out what happens. I will go ahead and simulate the code. So as you can see right here on the console that the value of J has been inserted in the first as a first element, as the 1th element or first element of the queue. So yeah, this is how we use dot insert. And other than that, there are several other methods. So like dynamic arrays, we also have dot delete. And suppose if I want to delete the first element of the queue, which is 1, I can simply do that by writing queue dot delete, and I will point the first element inside the bracket, and then I will save the code and run it again. Instead of strobe, I will use $monitor so that it can continuously monitor any changes. I think it will be much better. Just give me a second. I will write the $monitor in other initial block. So let's run the code for one more time. So as you can see right here that we successfully deleted the first element of this queue, and we did that using the delete method. So remember, during the introduction of the video, I told you that queue supports LIFO and FIFO behavior. So there are several methods using that we can perform those operations, and those particular operations are very fast and efficient for queues. So if you are dealing with a data structure or a data type where number of elements shrinks or increases a lot, queue is the first choice. So let us write that particular method. I will do that in the next time slot. So suppose if I want to enter any value in the head of the queue, I can do that using queue dot push underscore front, and inside the bracket I have to mention the value. So let's add 6. So what this will do, it will add 6 inside the queue and towards the head of the queue, which is the 0th element. So let's find out what does this do. So as you can see right here on the console that the 6 has been pushed as the 0th element of the queue. So similar to similar to push operation, we can also perform pop operation. So let's perform a pop operation using the pop method. So I can do that simply by writing Q, and suppose I want to pop the tail, the last element, I can do that by writing Q dot pop underscore back. So what pop will do, it will just delete the last element because I have declared here pop back. And since we are deleting element, we don't have any argument to be passed inside the bracket. So let's go ahead and run the code. So as you can see right here that the last element of this queue, which was 5, it is deleted. So this is how we can use pop method, and what we can do, we can also pop or delete the last element and assign it to another variable. So suppose if I want to delete 2 and store it to j, I can do that simply by writing j equals to q dot pop underscore back. So what this will do, it will remove 2 from here and it will assign it to j. So let's find out. I will create another dollar monitor for j, or instead I will write the formal argument here only. Q and j. Okay. Now let's run the code. As you can see right here that the value 2 was deleted from Q and it is assigned to J. So this is how useful the shrinking and increasing the size of Q is. So remember I did the pop operation in the back. I can do the very same thing in the front. So what if I want to remove 6 from Q? I can do that simply by writing okay, let's say I want to remove the first element of the Q and assign it to J. I can do that simply by writing J equals to Q dot pop underscore. This time I will write front. So what this will do, it will remove 6 and it will assign the value of 6 to J. So let's run the code. So as you can see right here now, the 6 value of 6 is removed from Q and Q is only left with 0 and that 6 is assigned to J. So it is that simple. And similarly, like we did push front, we can also do push back. So I will do that. Let's give push underscore back and let's give the value of 14 and let's run the code for one more time. So as you can see right here that the 14 has been pushed to the back of this queue. So what happens if you call the delete method, but if you don't pass any arguments, so if you don't pass any formal argument, it will just go ahead and delete everything inside the queue, including its dimension, its value, everything. So let's run the code again. So as you can see right here, we have an empty queue. So let's move on with other way of inserting, popping or pushing the values at front or back. and I find that particular way to be way more simple. So suppose let's let's initialize one more queue, and I will name that queue Q2, and let's give some value to Q2. 3 and 4. So what if I want to insert the elements of Q2 inside the queue with other values? I can do that by simply writing Q equals to the curly brackets, and inside this bracket let's give the first element a value of 12, then let's say 23, and then all the elements which are inside Q2. So we can just simply write the Q2. So doing that, we will have 4 elements. The first 2 elements will be 12 and 23, and the remaining 2 elements will be the elements of Q2. Those are 3 and 4. So let's run the code and find out. So as you can see right here that the 12 and 23 are being assigned as the first 2 elements, and the remaining 2 elements are the elements of Q2. So we can do many other combinations using this curly brackets. So suppose if I want, uh, let's say if I want to enter in the second element, I want to enter the value of J and the Q itself. I can do that by simply writing Q equals to Q, and I will declare a range that this Q will have the first 2 elements of itself, that are 12 and 23. So I will declare the range of 0 to 1, and the next element, that is the second element, will be J, and the next element, that is the third element, should be Q itself. So this entire value. So I will just write Q, and then the final elements will be the remainder of the elements, that are 3 and 4. So I can do that just by writing 2, and we can write it till till the fourth element, but till the third element, but instead of that I will write dollar. So it signifies that from 2 till the end of the last element. So using that, we will run the code. So as you can see right here, I made such a complicated combination of elements within a line. So what I did, like first I mentioned the first two elements to be of Q itself. Those are 12 and 23. And the next element should be J, J6. So 6 right here. And then the next element is the Q, the entire Q, which was 12, 23, 3, and 4. And you can see it right here, 12, 23, 3, and 4. And the last elements should be the two last elements of the Q, 3 and 4, 3 and 4. So I just inserted J and Q in the between the first and the second element. So it's very simple. I can do that, and with other queues also, I can insert the values of other queues by writing suppose if I want to change this queue to be if I want to replace the remainder of the elements with J and Q2, I can do that by simply writing a second 0 1. So I want the first two elements to be retained, and I want the next elements to be replaced with J and Q2. So I will save the code and run it again. So as you can see right here that using this we have retained the first two elements, but the next elements are replaced with the value of J and the value of Q2. So using this curly brackets, we can also replicate some of the methods right here. So I will go ahead and replicate the delete method. What if I want to delete the second element, which is 6 right here? I can do that by writing q equals to. So to do that, I will mention the first two element, the range containing the first two elements, and those are 0 to first. And next, I will skip the second element. So I will just mention the third element till the last element. Q, the third element, and to signify the last element, we just use dollar. So here, the second element will be removed because we haven't mentioned any second element. So we didn't mention the second element here. So like if you will run this, it is just the same thing. It's the complete queue. But here we are not mentioning the second element, so it will remove the second element from here. So this is the equivalent of delete method. So let's go ahead and run the code and find out whether 6 has been deleted or not. So yeah, the 6 has been deleted. So similarly, we can perform the other operations, and we can do that by simply, so what are the other options left? So suppose if we want to perform an insert operation and we want to insert a value in the front, we can do that using these curly brackets. So suppose I want to insert 13 at the front, I can write 13, comma, Q. And this will just add 13 as the 0th element of this queue. So let's simulate the code. So as you can see right here that we were successful in adding 13 and inserting 13. So here we replicated the insert method. So we can also replicate the other methods such as pop back, pop delete, but I will advise you to use or stick with these methods only because it will take more than two statements to do the same thing. So suppose for the sake of this example, if I want to replicate the pop back operation, I can do that by simply writing, and what I want to do, I want to just pop the last element of the queue, that is 4, and assign it to j. So I can do that just by writing j equals to q, and if you want to view or point to last element, you just have to write dollar. So this will assign the last element to j, but still it is not a complete pop back operation because we are not deleting the last element in that queue. We are just assigning it to j. So to delete the last element, we just have to write one more line, and we will write q equals to q, q equals to q, and we will declare a range that is from 0 to the last element minus 1. So basically this will just delete the last element of this queue and assign it to itself. So let's run the code. So as you can observe right here that j gets the last element of q, which is 4, and the last element is popped out of the queue. So it is the equivalent of pop back or this particular line, but it takes more than one line to do that. So similarly, we can perform the pop front operation by writing j equals to q, and if you want to do a operand operation, we have to assign the first element, which is 13 right here, to j, and then we have to delete that first element. So to reference the first element or the zeroth element, I just have to write 0. So it will assign 13 to j, and on the same time I want that first element to be deleted, and to do that I will just write q equals to q, and I will declare a range. I will skip the zeroth element, so I will write 1 till the last element. So by doing that I will skip the zeroth element, which is 13. So let's run the code once again. So as you can see right here that the first element in the previous time slot was 13, and it is popped out of the queue and it is assigned to j. So that's how we can replicate the behavior of these methods using these curly brackets or by mentioning the range. So other than that, we also have to replicate one last method, which is delete. And this one is very simple. We just have to write q equals to an empty queue. So just by writing an empty queue and assigning it to the queue itself, it will delete all the elements, and it's a sheer equivalent of the delete method, not the one with mentions the position. I'm talking about this one. So let's go ahead and run the code and find out whether this works or not. So yeah, as you can see right here that we have the empty queue. So this is all about queue. You can use the queue methods, and queue is ideal for the case in which elements shrinks or grows a lot. And you will find the usage of queues in scoreboard and checkers. So that's all about queues. I hope you find this video useful and stay tuned for more. Thank you so much.